Hi, I'm Scott, and today we're going to be talking about refining oil. So one of the most important questions we can answer is, where does oil come from? Well, the answer might surprise you. If you guessed dinosaurs, then you're correct. At least partially. Crude oil is a form of fossil fuel. As the name implies, fossil fuels come from animals and plants that have been decaying beneath the Earth's surface for millions of years. So, are we pumping T-Rex skeletons straight into our cars? Unfortunately, it's not quite that simple. Since it takes so long for animals and plants to turn into oil, most of it's trapped far beneath the surface of the Earth. So we use drills to build wells that can extract the oil and bring it to the surface. You've probably seen them before. They look a little something like this. And the oil that they're pumping looks like this. Now for the fun part. That black liquid is composed of many different compounds and molecules. For example, there are aromatic rings, which are circles of carbons all bonded to each other, and hydrogen molecules. In addition, there are alkenes, which are straight lines of carbon molecules with a double bond somewhere in the structure. On top of that, there are molecules composed of several carbon rings, all connected to one another. So how do we separate all of these molecules? Well, we use something like this, a distillation column. Distillation is a thermal separation process. It is based on the idea that the different components of crude oil have different boiling points. The tower is at its highest temperature at the bottom and at its coolest at the top. This allows the lightweight molecules to exit the top of the distillation column and the heavyweight molecules to exit at the bottom. A distillation column can be up to 230 feet tall. Once separated, the streams are then treated in various ways. Hydrotreating, for example, is a process in which contaminants in the oil, like sulfur and nitrogen, are removed by a chemical reaction with hydrogen. Hydrotreating is important in oil refining because it makes the product safer for the environment. Reforming is a process that changes the shapes of the hydrocarbon molecules. Circular molecules are more useful than linear molecules in gasoline. Hydrocracking is a process that uses hydrogen to crack or break oil molecules into smaller pieces so that they can be used for gasoline, jet fuel, diesel, and other useful products. Long-chain molecules are broken into smaller molecules that make up the useful products. The coker takes the heaviest part of the crude oil and turns it into a solid product called petroleum coke. Petroleum coke looks a lot like coal and can be used for many things. For example, it can be used as a fuel to make electricity. Now that we have the oil separated, we can use it in all sorts of applications, such as diesel fuels, waxes and polishes, gasoline for cars, and even jet fuel.